Hi guys, time to get started. Can somebody confirm it? Hi.
Hi, sir.
Hi. Okay. Now calculus 2. Calculus 2 is mostly about integration. Okay. In calculus 1, we did indefinite integrals, the definition and the substitution rule. We also did a little of the definite integrals. Okay. The definition of the definite integral and the fundamental theorem of calculus, right? So today we cover a little bit of new thing, the substitution rule for the definite integral, and but before that we review some basics stuff. Okay. Now look at the screen. On the screen you have all the basic formulas. All the basic formulas I want you to memorize. Okay. If you did calculus 1 last semester, you can still memorize. If you did calculus 1 long time ago, probably you want to take a picture or find the formulas from your notes. Okay, now I'm going to assume all of you guys can memorize all the basic formulas. Again, if you cannot, you take a picture and so you have a formula sheet. Okay. And also open handout number 1. Handout number 1, I believe part 2, we are going to use some questions to review how to evaluate the indefinite integral first. Okay. How about we just go over some questions? Okay. Now question 1. I'll cover question 1 on PowerPoint. On the screen, you have an indefinite integral. The question is in the nature of using the basic formulas. You probably, for all the terms, so for the last term, you can get antiderivatives, so directly from the formula. Okay, now let's recall. To get the answer to an indefinite integral, all we need is to get a particular antiderivative of the integrand, and then we plus an arbitrary constant c, and then we have the answer. We did that in Math 1.1. The question is straightforward. The only term you might have trouble is the last term. Okay, so how about we do the last term separately, and then we get the answer. Okay. To get the answer to the last term, we just get the indefinite. Sorry, I forgot to change the color. Now, before we do the question, we are going to review how to get the indefinite integral of. So basically, the last term without including the factor of 2. Okay, we evaluate the indefinite integral. The numerator is 1, and the denominator is fourth root of x cubed. And by the way, the question is probably one of the questions on one of you guys' final exam. Okay. I'm just going to use some questions to review some basic stuff. Okay. The integral is in the nature that we need to use the power rule. The power rule is for handling the indefinite integral of a power function. So before we can use the power rule, we need to convert the integrand, the function, to the form of a power function. Okay. So to do that, we convert the function to the form of a power function. Okay. So we have dx in here. Okay. The function is 1 over fourth root of x cubed. Okay. convert the function to the form of a power function, we have x to the power of negative 3/4, I believe. Okay. Now we can use the power rule. So now let's recall the power rule says to get the indefinite integral of a power function x to the power of n. Of course, when n is not equal to -1. When n is not equal to -1, the indefinite integral of the power function like that is equal to I think x to the power of n plus 1, right? And then the coefficient, the number before the function, is 1/n plus 1. Okay. The definite integral of that, the indefinite integral of that is equal to this function and then plus c. For any indefinite integral, there's an arbitrary constant c involved. Okay, it's always the case. Okay. Now the integral we are trying to evaluate is a particular case when n value is equal to -3/4. We just use the formula, right? So the antiderivative of the function is x to the power of n plus 1. In this particular case, -3/4 plus 1. Okay, I think we have 1/4. This number plus 1, -3/4 plus 1, we have 1/4. Okay? And then the number before the function, is the reciprocal of exponent. I told you before. If you have 1/4 in here, you invert the numerator and the denominator, you have the number before the function. Okay, you have the coefficient. So you have 4 in here, right? You invert 1 and 4. The reciprocal of 1/4 is 4. Okay. And then the answer to that, you should plus a arbitrary constant c. Okay. If you evaluate the indefinite integral, we need to include a constant c, arbitrary constant c. Okay. Now let's recall the indefinite integral as represents all antiderivative of the integrand, right? So we just mentioned how to evaluate, how to get an antiderivative of the last term. Now for the given function, maybe I'm going to paste again. For the given function, you just integrate term by term. For all other terms are straightforward, right? Now look at your picture you just took. We got antiderivatives of these terms one by one. Antiderivative, you think which function has the derivative of psi? Which function has the derivative of psi of x? That's antiderivative of psi of x. So don't be confused with the derivative and antiderivative. For antiderivative, you think which function has the derivative of psi of x. Okay. Antiderivative of psi of x is negative cos of x, right? And then plus antiderivative of cos of x is sine. Okay, 3 times sine of x. Okay, and for this term, you think which function has the derivative of cosecant square of x? I believe it's negative cotan of x, right? All these guys are coming from the basic formulas I told you to memorize. Okay, and the antiderivative of x is half of x squared. Or you can write 1/2 times x squared. Okay, and the antiderivative of x cubed is, you just use the power rule in here. You have I think 1/4 of x to the power of 4, right? And then plus 2 times of that. So do not forget the factor of 2. Okay, 2 times 4 x to the power of 1/4. So this one is supposed to be the antiderivative of that. Okay, multiply this number by 2. I think you have 8 times x to the power of 1/4. Okay, so do not forget to plus c. Okay. Again, the question is designed for using the basic formula. Okay. I just reviewed how to evaluate antiderivative of radical functions. In many cases, a radical function can be converted to the form of a power function so that you can use the power rule. Okay, we did question 1. For the assignment, you are going to have a similar question to do. So basically, now we move on to question 2. Okay. We're going to do a few questions in the nature of the substitution rule for indefinite integrals. Okay, we'll do question 2. After this, I will give you a few questions to try. Okay. So because we have people who took calculus 1, I think last year, so I need to do some detailed review. Last year? Everybody took it last year. Sorry. Okay, now this question is in the nature that we need to use the substitution rule. Okay. Now let's recall the key to use the substitution rule is to choose u, right? To choose u, you treat the integrand as the product of two functions. Choose u so that one function as a function of u has easy to compute antiderivative. The other function is the derivative of u times a constant. I'm going to recall my point. Okay. The integrand is the product of two functions. So in this case, we treat the integrand as, I'm going to rewrite the integrand in slightly different form. Okay. In the form of square root of natural log of x and then times 1 over x and then dx in here. So do not forget dx is part of the integration notation. We said that over and over again in Math 101, right? Again, I want to repeat how to choose u. To use the substitution rule, the key is to make the substitution. The key is to choose u. Okay. Choose u as a function of x so that one of the two factors is a function of u with easy to compute antiderivative. The other factor is the derivative of u times a constant. Anybody want to write down how to choose u? I'm opening my chat.
Yes, sir.
So please, so tell me.
Sorry,
Yeah.
Linux.
Yeah. Some people say it's ln x.
Yeah.
But I prefer to call it natural log of x.
Yeah, natural log.
Natural log of x.
Yeah.
Okay, sure. Thank you. Cool. So we choose u to be natural log of x. Okay. So maybe the solution to question 2. Okay. We let u be natural log of x. Okay. Still, I want to mention why we choose u to be natural log of x. Now, the integrand is the product of two functions. Choosing u to be natural log of x, then one of the two functions becomes the function square root of u, right? Natural log of x is going to be u, square root of u. This function has easy to compute, has easy to find antiderivative as a function of u. Okay. So because we can write the function as a power function of u, so that we can use the power, right? Choose u as a function of x, so that one of the two factors has easy to compute antiderivative. The other function is the derivative of u. This 1 over x is just the derivative of natural log of x, right? so that u will work. Choose u so that one function as a function of u has easy to compute antiderivative. The other function is a function of u. The other factor is the derivative of u times a constant. Okay, that's how we choose u. Okay, and then we follow the routine. After choosing u properly, the majority of the work is done, and then all the rest steps are the same. Okay, after choosing u, then the next step is to compute the differential of u. The differential of u is denoted using du, right? Now let's recall the differential of u. The differential of u du is equal to the derivative of u times dx, the derivative of natural log of x times dx. For the first question, so maybe I'm going to write one more step. It's the derivative of natural log of x and then times dx. Okay, so do not forget dx is part of the notation, part of the differential notation. Okay, so which means du is equal to the derivative of natural log of x is 1 over x, right? So we have 1 over x and then times dx. That's the differential of u. Okay. The next thing we do is to convert the given integral entirely in terms of a function of u. We mentioned before, I want to repeat again. So do not write two variables in one integral. Okay, I know some professors do that, some instructors do that, but I do not want you to do that. Okay. In next step, I want you to write the integral entirely in terms of u. Okay, so do not write x and u in one integral. Okay, I will show you what I mean. Now the given integral. Now I want to convert everything entirely in terms of u. Probably you want to look at that line. We write the integral entirely in terms of u. I think in Math 101 I told you to box something. Okay, the stuff you box is the derivative of u times dx. Okay, so we box that. So in this case, we put that in the box. Okay, so that you can see how to write the integral entirely in terms of u. Okay, as the integral of, for this part we write square root of natural log of x as square root of u, right? Because we want to write everything in terms of u. The stuff in the box, you see, the stuff in the box is in terms of u as du, right? That's what I meant by writing the given integral entirely in terms of u. Again, I do not want to see x and u in one integral. Okay. Now we just evaluate the new integral of u. Okay. It's a radical function which can be rewritten in the form of a power function, right? So the integral of square root of u can be written as u to the power of 1/2. And then the power rule we are going to use is the indefinite integral of u to the power of n, right? N is not -1. It's equal to, so now let's say 1 over n plus 1 and then u to the power of n plus 1. Okay, we use that formula. Can write the next line in here. We use the formula, so you have u to the power of 1/2 plus 1. So this is the particular case that n is 1/2, right? 1/2 plus 1 is 3 over 2. Okay. If the exponent is 3 over 2, then the number before that, or the coefficient, is 2 over 3. Okay. You just get the reciprocal of exponent. After getting a antiderivative, you need to plus c. Okay. That's almost the final answer, but not the final yet. Okay. the given function, the given integral is a integral of a function of x. The final answer, you need to write the final answer as a function of x. So which means the relation of u and x is here. Wherever you see u, you need to replace u with natural log of x. Okay. So the final answer is 2/3, and then you replace u with natural log of x. Natural log of x to the power of 3/2, right? And then plus c. Okay. From the final exam, I think I did not see many people having problems with a question like this. Okay. So you should be okay. Any questions about this? Okay. If you don't have any questions, we'll move on to do some more questions. Okay. Again, so calculus 2 is mostly about integration. We're going to learn some more integration techniques, and then we learn some applications. And also we do a little bit of differential equations. Not maybe, we have to cover that. So UBC want that, and also some series and sequences and the series. Okay. Integrations, application of integration. Okay, and then differential equations, series. That's about it. Okay, for this one, so before we choose u, I'm going to rewrite the function in slightly different form. Okay, so the integral is equal to the integral of 1/, I think you have cube root of x squared minus 4, and then you have x in here. Okay, you remember what I said about how to choose u? Choose u to be a function of x, so that one of the two factors becomes a function of u with easy to compute antiderivative. The other function is the derivative of u times a constant. Okay. Anybody want to tell me how to choose u, or write down how to choose u?
X squared minus 4, sir.
Yeah, x squared minus 4 is right. Cool. So can I divide the thing into two parts? So let u be x squared minus 4. Okay. And then one function will become 1/, cube root of u, which is essentially a power function, right? So the other function is the derivative of u multiplied by a constant. Okay. That's how it works. Okay, now the next thing we do is to compute du. Du is called the differential of u, right? The differential of u, you take the derivative of x squared minus 4. You have 2x and then times dx, right? After that, we are almost ready to write the given integral entirely in terms of u. Okay. Again, one function is can be written as a function of u with easy to compute antiderivative. In method 1.1, I told you you can imagine a box. So the other function, so which is the derivative of u times a constant, together with dx, the factor of dx, you put that in the box. And then from the differential, I wanted you to solve that equation for the box. Okay. This will help write the the given integral as a new function, as a new variable of u. The stuff I boxed is here in the differential. Actually, as long as you choose u properly, then the stuff in the box can always be written as a number times du, as a constant times du. Okay. And then we solve that equation for the box. We want to write the stuff in the box as a number times du. Okay. So x times dx, the stuff in the box, can be written in terms of u as 1/2 times du, right? You divide two sides of the equation by 2. You have that. After writing the stuff in the box as a number times du, then we are ready to write the given integral entirely in terms of u. Okay, I will show you that. The given integral, now we are ready to write the given integral entirely in terms of u. Okay, yeah, probably you want to look at here, so which is the same thing as the given integral. Okay, that factor can be written as a function of u as, so do not forget the integration notation. That factor is written as a function of u as 1 over cube root of u, right? So because our u is x squared minus 4, you have cube root of u on denominator. Okay. And the stuff in the box is half of du. I can leave the constant factor 1/2 out of the integration notation. So you have dx in here. Okay. Sorry, du. You have du in here. Again, now we have an integral of u. Do not write x and u in one integral. Okay. The radical function here is essentially a power function. Convert the function to the form of a power function, so we can use the power rule. Okay. So here we have the indefinite integral of u to the power of negative 1/3, right? Negative 1/3. Now we are ready to apply the power rule to get antiderivative of u to the power of negative 1/3. So we have 1/2. To get antiderivative of negative 1/3, so you have u to the power of negative 1/3 plus 1. I'm talking about the power rule. Okay. Negative 1/3 plus 1, I think you have 2/3. And then if your exponent is 2 over 3 in here, you invert the numerator and the denominator. You have the coefficient before the function. Okay. You should have 3 over 2 in here. Okay. Right. Invert 2 over 3, you have 3 over 2. Okay. And then plus c. Do not forget c. Do not forget c. Okay. In the last step, we are going to write the final answer as a function of x. We combine these two factors. We have 3/4. 3 over 4. And then we replace u. The relation between u and x is always here. Okay. We write u as x squared minus 4. So we have x squared minus 4. And then to the power of 2 over 3. And then plus c. Okay. When talking about integration techniques, we do not simplify. In most cases, we do not simplify. So by that I mean you can leave the final answer like that. You do not have to convert the answer as a function of as a radical function or whatever thing. Okay. So we did question 3. Okay. Any questions? If you don't have any questions, I want you to to get a piece of paper, I'm going to ask you to try one question. Okay, the following question is going to be a in-class quiz question. So please. I didn't copy the integration notation, but yeah, because I want you to do the indefinite integral first. So later on, we are going to talk about how to compute the how to do the substitution rule for the definite integrals. Okay, try that. So that's a in-class quiz. So before you move on, I'm going to rewrite the integral in slightly different form so that you can see how to choose u. Okay, I'm going to reverse the order of the two factors. One factor is sine of x squared. Probably I want to put brackets here, and then times x, and then times dx. Okay, and then I want to tell you how to choose u. Actually, I want you to tell me how to choose u. Choose u so that u cannot be too complicated. Choose u so that one factor as a function of u has easy to compute antiderivative. The other factor is the derivative of u times a constant. Anybody want to tell me how to choose u, or write in the message how to choose u?
Is it x to the power 2?
Yeah, choose u to be x squared. Choose u to be x squared, x to the power of 2. Okay. Let u be x squared. Okay. And then I want you to, I will give you a few minutes to try to complete the solution, and then probably I can give you some hint if you have any questions. So please, I will give you 5 minutes to. You don't need 5 minutes. You just keep on going. Okay. Just try that. You keep on trying. I'm going to write slightly behind you so that you can see if you did it right. For this question, I do not want you to copy. I want you to try it on your own. Okay. The next step is always get the differential of u. The step after that is always solve that equation for the box from the differential of u. The box is always the other function, one of the factors together with bx. Box is here. By the way, you do not have to write the box. I'm just showing you how to think. The stuff in the box can always be written, as long as you choose u properly, the stuff in the box can always be written as a number times du. So in this case, you divide two sides of the equation by 2. I think you have 1/2 of du, right? Now you are ready to write the given integral as a function of u, as an integral of u. Right, let's sum it up. Actually, you look at here. So this integral as an integral of u is, I think, 1/2. You leave out the constant factor 1/2 out of the integration notation. What do you have in here? You have, I think, sine of u and then du, right? I will stop here. Okay, I will give you 2 more minutes, and then that's one of the in-class quiz questions. Okay. Yeah, that's good. That's good. I think Tyler wrote the final answer on in chat. That's right. I think that's right. Anybody want a longer time? If you don't, we'll move on. We'll move on to talk about the substitution rule for the definite integrals. Okay. The substitution rule for definite integrals. Okay. For the people who took my calculus not last semester, probably I covered that already. So, but last semester I lost too many classes, too many holidays. I think this semester I'm going to lose many holidays too. Okay. So I did not cover the substitution rule for definite integrals. I'm going to do that now. Okay. Actually, before we do the the substitution rule for the definite integrals, I will review how to use the fundamental theorem of calculus to evaluate the definite integrals. Okay. I told you in Math 101 that's one of the most important human discoveries in history. Okay. It's called the fundamental theorem of calculus. Okay. Actually, the conclusion has 2 parts. For the purpose of this class, we just review part 2. Okay, part 2 of the fundamental. I just call it part 2 of the fundamental. Okay. Okay. So now let's recall given an integral, a definite integral, So now let's say that. The condition is the function is continuous. Okay. If the function I do not have to write the function. If the function f of x is continuous, and with a antiderivative of uppercase f, sorry, I forgot to mention the lower limit and the upper limit. Given a definite integral of that, of the definite integral of the function from a to b. Okay, now the formula you need to know is the definite integral of the function to get the definite integral of f of x from a to b. That's a definite integral. Okay, we did the definition, which is the definite integral is defined as the limit of the Riemann sum, right? The procedure is pretty long. I think many of you guys did okay on the final exam. Okay. I believe you can remember that. Okay. The definite integral of the function f of x from a to b, as long as you can get a particular antiderivative of the function, and then the definite integral can be computed using, I'm going to mention the symbolic notation first. Is equal to, you use the antiderivative, and then you put a notation something like this. You write the upper limit b in here, and then you write the lower limit a in here. So that's a symbolic notation. The meaning of the notation is the difference between two values of the antiderivative. One value is the value of the antiderivative at upper limit of b. The other one is the value of the antiderivative at the lower limit of a. Okay. I'm talking about this in detail for the people who took the course a long time ago. The symbolic notation, the meaning is, can I write 3 bars for to tell me is the meaning of this notation? The meaning of the notation is the value of the antiderivative at b, okay, at the upper limit of b, minus the value of the antiderivative at the lower limit of a. Okay. That's one part of the fundamental theorem of calculus. Okay. I'm going to use a particular question to show you how to use the fundamental. I think I can squeeze it here so that you can see the content and the question on the same screen. Now, for instance, if I'm looking for the definite integral of, let's say, sine of x from 0 to half pi. So do not forget dx is part of the integration notation. Okay, so do not forget dx. Okay. For this one, all we need to get the definite integral of a function, all we need is to get a particular antiderivative of the function, and then a antiderivative of sine of x is negative cos of x, right? It's negative cos of x. We get a antiderivative of the function. And by the way, this part can be replaced with a square bracket, with square brackets, okay, if the antiderivative is a little bit long. Probably I'm going to use square brackets, okay. You enclose the antiderivative in square brackets, and then you write upper limit of the definite integral here. You write the lower limit of the definite integral in here, okay.
Would you regularly have plus c in there because you calculated the antiderivative?
No, the answer to a definite integral is a number. The number is computed using the difference between two values of the antiderivative. The answer to indefinite integral without these two numbers is a function plus c. Now we are talking about the definite integral. The answer to definite integral is a number. Now let's recall the geometric meaning. If the function is non-negative, then the meaning of the definite integral we learned in Math 101 is the area under the curve. Remember that? So the answer to the definite integral is a number. There's no constant c involved. Actually, for the antiderivative, you just need a particular antiderivative here. You do not need c. Actually, effectively, with or without c is the same thing, because you subtract two numbers anyway. You just remember the fundamental. In the fundamental, there's no c involved. You just need a particular antiderivative. Okay, a very good question. Now all we need is to plug in numbers. Okay. We have a symbolic notation here. The meaning of the notation is the difference between two values of the antiderivative. You plug in pi over 2, right? So you have the value of the antiderivative, negative cos of half pi, right? So that's the value of the antiderivative at upper limit minus the value of the antiderivative at the lower limit. The lower limit is 0. Okay. Okay. Now you need to recall some trig values. Cos of half pi is equal to 0. Cos of 0 is equal to 1. At this point, you really should memorize these trig values. Okay. The value, so this term is 0, right? Negative 1. So the final answer is 1. Okay. That's a simple question showing you how to use the fundamental. Okay. Again, to evaluate the definite integral, you need to get a particular antiderivative of the integrand. And then the answer is given by the difference between two values of the antiderivative. I think I said it right. Anybody can remember the geometric meaning of the answer?
Mr. C?
Yes.
Why is it a double negative?
And so because the I'm trying to
okay.
the meaning is the difference between two antiderivative. You plug in this number and then you minus the value of the antiderivative at 0, right?
Yes, I was looking at one equation. I didn't see the other one.
It's okay.
Never mind.
Okay, no problem. Okay, yeah, that's one. Anybody can recall the geometric meaning of the integral? It's quite interesting, actually. Okay. This function sine of x, I believe you can remember the graph. This function sine of x is non-negative in between 0 and half pi. I think I can tell you the graph right now. Okay, the whole sine of x is something like this, oscillating in between 0 and 1. But now we are talking about the function when x is in between 0 and half pi, right? In between 0 and half pi, the function is something like that. This point has x coordinate of half pi, I believe. And you have 1 in here, right? So the whole function, I'm going to use the dotted line to denote the whole sine of x. The solid part is the function over the interval from 0 and half pi. Actually, now I'm trying to ask you what is the geometric meaning of the number. In calculus 2, we are going to learn the area between curves and so on. But using the geometric meaning of the definite integral, you should be able to answer this. Okay, I'm going to review this. Okay, as the area under the curve when x is in between 0 and half pi. Amazingly, the area of the shaded region here is equal to 1. Most likely, we did that question in Math 101. Okay. That's how to use the fundamental. Now we're going to talk about the substitution rule for the definite integral. Okay. I will write the title. The title is for definite integrals. That's my S. I'll use a new slide. Actually, compared with the indefinite integral, there's only one additional step you need to do. It's easy, so don't worry. Okay. Again, for the definite integral. Question?
Title for the slide again?
Okay. The substitution rule for the definite integrals. For definite integrals. You got it?
Yes, thank you.
Okay. Okay. You see the integrand is a little bit complicated, so we do not have a handy formula to evaluate to get antiderivative. Okay, so we have to do something different. Okay. Again, I'm going to rewrite the integral to a different form. Okay. To sine of x squared, you put that in brackets. And by the way, it's kind of essential to put that function in brackets. Okay. Or otherwise the notation could be confusing, right? The definite integral from 0 to square root of half pi. Right. The way to choose u is the same. The way to choose u is the same. Now the integrand is the product of two functions. Choose u as a function of x, so that one function becomes a function of u with easy to compute antiderivative. The other factor is the derivative of u times a constant. The way to choose u is the same. So because we just did the corresponding indefinite integral, right? So you know how to choose u. So choose u to be x squared, right? You know how to get antiderivative of sine of u. So the other factor is the derivative of u times a constant. Right. I told you only one additional step. The next step is the same thing. You compute du, the differential of u. The differential of u du is 2x. You differentiate the function, right? And then times dx. I told you there's only one additional step. I still put the other function together with dx in the box. Okay. When you actually do the question, that's your imaginary box. We still solve the equation for the box from the differential. Now, in next step, we want to rewrite the integral entirely in terms of u. Okay. In the given integral, this is x value. So that makes sense? This is x value. I told you earlier, in the new integral, I want you to write everything in terms of u. This time, everything is going to be in terms of u, including the lower limit and upper limit. So basically, we're going to convert these x values to u values so that the new integral is going to be completely in terms of u. Okay. To make the meaning clear, it's not essential to do that. In the given integral, I'm going to write x equals 0 in here to mean the lower limit is a value of x. I'm going to write x value of x equals square root of half pi in here to mean the upper limit is a value of x. You do not have to do that. It's not essential. If the function is a function of x, by default, these two numbers mean x values, right? Now we need to convert these numbers to u values so that the new integral is going to be entirely in terms of u, including the lower limit and upper limit. So by that we mean we need to get the u value for x value of 0. 0 is coming from the lower limit. When x value is 0, so what's the u value? Anybody want to tell me? The relation between u and x is here. X value of 0 implies, that's the standard notation saying implies. X value of 0 implies u value. The relation between u and x is here. Okay, u is x squared. When x value is 0, u value is 0 squared. So which is 0. Okay. Right. Again, that's u value for the x value of 0. Later on, when converting the new integral to a new integral, we need to have that as a lower limit. Right? And likewise, we need to get the u value for x value of the upper limit, which is square root of half pi, I think. Square root of half pi. When x value is square root of half pi, it gives you the u value of so basically you take the square of x value, you get the u value. It's easy, right? U value is equal to half pi. So that makes sense. Now in next step we want to write everything in terms of u, okay, including the lower limit and the upper limit. So can I just continue from here? So here I'm using these notations to indicate these are x values. Okay. Now I'm going to write everything in terms of u values. We'll do the new thing later, but this function now becomes sine of x squared. Sine of x squared in terms of u is sine of u, right? The stuff in the box is half of du. Half of du. I'm going to put the constant factor for the integration notation. Okay. And what? Anybody want to guess the lower limit? The new lower limit? That's a
0.
That's a new integral of u. These two limits, lower limit and upper limit, are supposed to be u values, right? This is the only question I'm going to use u equals 0. I think some people do use a notation like this, but I'm trying to say x value of 0 will become u value of 0, and the x value of square root of half pi will become u value of here, right? Half pi. That's the only new thing. The new thing is you need to get the u values for x value of the lower limit and the upper limit. Okay. Again, the answer to a definite integral is a number. We are looking for a number. I forgot to mention one other thing. To evaluate indefinite integrals, you need to write the final answer as a function of x and then plus c, right? But for the definite integral, after using the substitution rule, you do not go back to x. You just evaluate a new integral of u. At this point, you forget about x. Okay, you just evaluate the new integral of u. What I meant is, do not go back to x. You just imagine that's a new question. Okay, you do the new question from here. So you have 1/2 in here. Get antiderivative of the integrand, so which is negative cos of u, I believe, right? I should have used square brackets, so but it doesn't matter. Okay. And then you put in the upper limit of 1/2 in here. Okay. And then put the lower limit of 0 in here. Okay. Probably you want to write u equals 1/2 u equals 0. To be consistent. So with these notations. Okay. And then you plug in numbers, you can have the answer. Okay. Again, so do not go back to x. That's a new integral of u. Everything is already in terms of u. You just get the final answer. Okay. I think you have 1/2 of plug in upper limit. I think you have negative cos of half pi, right? And then minus negative cos of 0. I think the final answer is 1/2. Is that right? Cos of 0. Again, cos of 0 is equal to 1. Cos of half pi is 0. Okay. So that's the whole story about the substitution rule for the definite integral. Okay. I told you there's only one additional step. The additional step is to convert the lower limit and upper limit to u values. Again, so do not go back to x. After you have an integral of u, you just evaluate the integral from here. You'll get a number. Okay. I will give you a few more steps. Okay. Du is that 1/t times dt, right? And then I think the final answer is right. And then your box is here probably. Okay. And then you need to get u values for x values of 1 and e. So this time you do not have to write x equals e, x equals 1. I will show you another way to write it. So, but by default, that's x value. That's x value, right? We need to convert x value of 1 and x value of e to u values. So x value of 1, the lower limit, the relation between u and t. Sorry, I said x. It should be t. The lower limit t value of 1, the lower limit t value of 1 corresponds to u value of natural log of 1, you need to record the value of natural log of 1. Natural log of 1 is equal to 0, right? Now let's recall, to get natural log of 1, you think natural log is a log with the base of e. You think e to what power is equal to 1? E to the power of 0 is equal to 1. That's why natural log of 1 is equal to 0, right? Okay, and then t value of e will give you the u value of natural log of e. Natural log of e is equal to 1. Okay. So the given integral, I'm going to continue from here. The given integral is now you are ready to convert everything in terms of u, including the lower limit and upper limit. So here t value of 1 corresponds to e value of 0, and t value of e corresponds to u value of 1, right? And then that's u. You have u squared. The whole thing in the box is nothing but du. I think 1/3 is right. Okay, 1/3 is right. I believe you can go from here. Okay, I will stop here.